How do you stop a 26-ton spacecraft hurtling through space at 25,000 miles per hour? The answer sounds simple, but terrifying. You slam it into a wall of air. That means temperatures soaring to 5,000 degrees, a total communications blackout, and a maneuver so precise it can only be compared to skipping a stone across a pond at Mach 32. But even that is not the whole story. Engineers also have to deploy multiple layers of parachutes to control this compact monster of a capsule and slow it down before it hits the ocean. This is the first stage of re-entry. About 20 minutes before reaching Earth's atmosphere, the crew has to say goodbye to the European service module. Throughout the mission, it has served as the spacecraft's power source, life support system, and the quiet heart that kept everything running. But the module has no heat shield. Explosive bolts fire, the module separates, and it burns up like a shooting stars over the ocean. At that point, the 4 astronauts are alone inside Orion, a small, rugged, cone-shaped capsule pointed straight into the violent storm ahead. Then comes Stage 2. At about 75 miles up, the spacecraft reaches what is known as entry interface. Orion is now screaming toward Earth at 25,000 miles per hour, roughly Mach 32. To put that into perspective, every kilogram of the spacecraft at that moment carries nearly 2,000 times more kinetic energy than a commercial jet. It slams into the air with such force that the gas in front of it cannot get out of the way. Instead, it is compressed into a white-hot shock wave, heated to 5,000 degrees Fahrenheit, about half the temperature of the sun's surface. Then Stage 3 begins, and with it comes a terrifying silence. The heat becomes so intense that it strips electrons from the air, wrapping Orion in a glowing shell of plasma. That plasma sheath blocks all radio signals, cutting the crew off from mission control for several agonizing minutes. On the ground, the world can do nothing but stare at a blank telemetry screen and wait, while 4 human beings ride a fireball across the sky. To survive the violence of this return, Orion does something remarkably clever. Instead of plunging straight down on a deadly steep path, it skips. Thanks to its shape, the capsule generates lift and bounces off the upper atmosphere like a stone skipping across water. During the Artemis I test flight, one deeper skip caused parts of the heat shield to chip away under enormous pressure. So to protect the Artemis II crew, NASA adjusted the trajectory into a lofted, gentler approach. That is Stage 4. This softer dip allows the heat shield material to breathe, venting hot gases without cracking while also keeping the G-forces at a level the crew can physically tolerate. With about 4 minutes left, the fire finally begins to fade. The roar of plasma softens into a subsonic whistle, and the crew's voices finally crackle back over the radio. But it is still too early to relax. They are still 25,000 feet above Earth, and this remains one of the most dangerous parts of the entire flight. A small miscalculation could tear the spacecraft apart. That brings us to Stage 5. Once the speed has dropped to a manageable level, the capsule stops truly flying and begins to fall. The nose cover blows off, and 2 small drogue parachutes shoot into the slipstream. Their job is to stabilize the shaking capsule and pull it into an upright position. And just to be clear, these are not the main parachutes. A few moments later, the main event begins. 3 massive orange and white parachutes open in sequence, blooming like giant flowers against the blue sky. They slow the multi-ton spacecraft from hundreds of miles per hour down to a gentle drift of about 20 miles per hour, slow enough for a safe splashdown. Then comes Stage 6. Roughly 12 minutes after slamming into the atmosphere, the journey ends with a splash in the ocean. but even the final seconds are carefully calculated. The onboard software makes one last roll adjustment, making sure the capsule hits the swells of the Pacific at exactly the right angle to reduce the impact on the crew's spines. But how does all of this begin? Step 1 is leaving Earth. The mission starts at NASA's historic Kennedy Space Center. When the countdown reaches 0, 4 RS-25 engines and 2 giant solid rocket boosters on the Space Launch System, or SLS, ignite together, unleashing a staggering 8.8 million pounds of thrust. The rocket tears through the atmosphere, lighting up the Florida coast. Within just 2 minutes, the side boosters burn out and fall away into the Atlantic Ocean. The core stage continues pushing the spacecraft into low Earth orbit before separating, leaving the Orion crew capsule and the rocket's upper stage to continue the journey. Step 2 is the trans-lunar injection. Orbiting Earth is not enough. To reach the Moon, the crew needs one enormous push. As Orion circles Earth, the upper stage fires one last time. That burn accelerates the spacecraft to more than 24,000 miles per hour, fast enough to break free from Earth's gravity. Once the burn is complete, the upper stage separates. From there, Orion, powered by its European service module, coasts across the dark 240,000-mile void toward the Moon. Step 3 is the lunar flyby. What happens at the Moon depends on the mission. For the Artemis II test flight, the crew will not enter a traditional circular orbit.
The Orion capsule
Instead,
travels a long
they will use
egg-shaped
what is
orbit
called
around the Moon.
a free return
Here, Earth's and the
trajectory.
Moon's gravity are in near perfect
They will
balance.
fly around the
This
far side of the
equilibrium allows
Moon
for a stable
and use
fuel
lunar
efficient
gravity like a
mission.
giant natural slingshot, sending the spacecraft back toward Earth without the need for major engine burns. For future missions that actually land on the lunar surface, Orion will enter something called a near rectilinear halo orbit. You can think of it as a long, egg-shaped path where the gravity of Earth and the Moon almost balance each other out. It is extremely stable and saves a tremendous amount of fuel. Orion will park there so astronauts can transfer into a waiting lunar lander such as SpaceX's Starship and continue down to the Moon's south pole. To come home, we have to look at step 4, fire in the sky. When it is time to return, Orion fires its engines to break out of lunar orbit and begin the coast back to Earth. But the trip home may be the most dangerous part of the entire mission. Right before hitting Earth's atmosphere, the service module is jettisoned, leaving only the compact gumdrop-shaped crew capsule. Orion slams into the thick air at 25,000 miles per hour, or Mach 32. And in everyday life, if you are not careful with the speed of information in the digital age, you can also get hit hard by spam calls, junk mail, and online data breaches. That exposed data does not just lead to nuisance spam and scams. It can also affect your insurance rates and even lead to a loan denial at exactly the moment you need credit. Incogni helps protect your privacy by regularly scanning for data exposure and preventing data brokers from re-uploading your personal information to their systems. You also get a clear, real-time dashboard so you can track the status of your data. With Incogni's add-on plan, you can even use a custom removal tool. The process is simple. Copy the link to any site exposing your information. Open the custom removals tool, paste the link, and hit submit. Then wait about 30 to 45 days, and your data can be removed. If you want to take back control of your personal information, you can use Code AI through the link below, ekoi.com/etelli, to get 60% off an annual plan. So how does this compare with the re-entry process of Musk's Crew Dragon? Crew Dragon autonomously disengages from the ISS docking port, releasing the soft capture system and retracting the hard capture hooks. A gentle push from springs allows the spacecraft to slowly drift away from the station. Even though this process is automated, Manual backup systems are in place if needed. As Crew Dragon moves farther away, departure burns are performed using its thrusters. The first burn slightly increases the distance from the ISS. Once those burns are complete, the spacecraft enters independent flight mode, meaning it is now flying freely in orbit and preparing for the next phase of its return. To line up with the correct re-entry path, Crew Dragon carries out additional burns and orbital adjustments. It gradually lowers its orbit through a series of controlled maneuvers, placing itself in exactly the right position for the critical deorbit burn. This is a crucial step, carefully planned by mission control to guide the spacecraft toward its designated splashdown zone. The Draco thrusters fire for several minutes, slowing the vehicle and steering it toward Earth's atmosphere. Right before re-entry, the trunk, which contains the spacecraft's solar panels and radiators, is jettisoned and left to burn up in the atmosphere, while the capsule continues its controlled descent. As Crew Dragon enters the atmosphere, it reaches the most intense phase of the journey. Traveling at speeds above 17,500 miles per hour, the capsule endures extreme heat and pressure, with its heat shield protecting the people inside. The buildup of plasma around the spacecraft causes a brief communications blackout, a normal but dramatic part of re-entry. Once the fiery descent is over, the parachute deployment and splashdown sequence begins. At around 18,000 feet, or about 5.5 kilometers, two small parachutes deploy to stabilize the capsule. A short time later, at 6,000 feet, about 1.8 kilometers, four main parachutes fully open, ensuring a smooth and controlled descent. Finally, Crew Dragon splashes down in either the Atlantic Ocean or the Gulf of Mexico, depending on weather conditions. Immediately after splashdown, SpaceX recovery teams arrive by boat, secure the capsule, and help the astronauts out. After initial medical checks, the crew is transported back to land, bringing their journey home to a successful close.